Inside the smartphone are 62 microchips containing a total of 90 billion transistors. These microchips are incredibly powerful and the cornerstone of all technology. But how are billions of nanoscopic transistors manufactured into a microchip the size of a tiny ant? Well, all these microchips were manufactured in a semiconductor fabrication plant like this one. Inside it is a clean room, which spans the area of 8 football fields and is filled with hundreds of machines, ranging in size from that of a van to that of a city bus, and costing anywhere between a few million and $170 million. Within this microchip factory, silicon wafers travel from machine to machine and undergo around 1,000 processes over a 3-month period. And by the end of production, each silicon wafer will be covered in hundreds of CPU chips, each containing 26 billion transistors. When we zoom in, we can see the nanoscopic transistors at the bottom and over a dozen layers of wires above. This integrated circuit is then cut out from the wafer, tested, and packaged so that it can be installed into your desktop computer. In this video, we're going to explore the entire microchip manufacturing process and show you how billions of nanoscopic transistors and an impossibly complex 3D maze of wires are manufactured in one of the world's most technologically advanced microchip factories. It's an incredibly complicated process, so stick around and let's jump right in. A portion of this video is sponsored by Brilliant.org. There are 2 sides to understanding how microchip manufacturing works. The first is the sequence of steps and processes needed to build the nanoscopic transistors and the labyrinth of wires. Whereas the second is how the semiconductor fab and multi-million-dollar equipment of the clean room floor work. And we'll be flipping between these 2 sides to get a complete picture. Let's start by opening up this desktop computer, focusing on the CPU and taking a look at what's inside. Here we have an integrated circuit, or die, which we'll refer to as a chip. This chip has 24 cores, a memory controller, a graphics processor, and many other sections. Within one of the cores, we can see its block diagram and the various elements. Zooming in on this multiply block, we find a layout of 44,000 transistors that physically execute 32-bit multiplication and constitute just 0.00017% of the overall 26 billion transistors